I invited some people that are intimately involved in the rulemaking process and will be part of the implementation when the rules get set. And so I want to introduce who's here today. Joey Hester used to work for Soil and Water. Now he works for a Division of Water Resources in the Department of Environmental Quality. Allie Dinwiddie works for the Division of Soil and Water, and she works along with Julie Henshaw. Both of them are going to be presenting today, as well as myself. The reason we're meeting today is to give you a window into the rulemaking process, some of the agricultural practices that are used, so you all can be thinking about what may be possible, what may not be possible, and also to possibly get you engaged in the rulemaking process. Joey will talk about that. I want to start with a discussion of the water quality problem, and Joey's going to begin that presentation. So take it away, Joey.
All right. Thank you, everybody, for joining us this morning. One thing that I want to sort of lay out at the beginning is that this is probably the first you'll be hearing from me. I do anticipate to over the next few years, keeping in regular touch with all of the stakeholders, as many of the stakeholders as I can. So this is going to definitely be an ongoing dialogue. There will be a formal process this year, but it kind of drags out. There's any number of steps that we're hoping to get input from all the ag stakeholders in the watershed. So this is just the beginning in a long line of outreach that we hope to do. So the background here, and this is just to give you a sense of how long-standing this issue is. High Rock Lake has been classified as eutrophic since the early 70s. As is generally the case in any freshwater reservoir, they kind of, by definition, they tend toward eutrophic status because they're a sink for anything that drains through the watershed and ends up in the final receiving waters. The DEQ, Van Diener, noted in 1992 that it was classified as the most eutrophic lake in North Carolina. That's the first time that any formal recommendation for a nutrient strategy was put on the table. So this discussion has been going on for a long time. It was first put onto the 303D list of impaired water bodies for violating the chlorophyll A water quality standard in 2004. You may have a question as to why it took so long for it to actually show up on the impaired water bodies list. That had to do with ongoing differences in methodology and implementation of those assessment methods. It tends to change every few years based on resources and data availability. So eventually it did actually get declared formally impaired for chlorophyll A violations. There were some major fish kills in the 2000s. Those garnered enough attention that there were phosphate limits put on 3 wastewater treatment plants in the Abbott's Creek arm, which is, if you're looking at the 5 major arms of the watershed, it's on the right side. It does have ongoing persistent algae blooms in basically every season except the winter season. I don't think that it still carries the status of the most eutrophic lake in North Carolina. There are probably other water bodies that have that title now, but it is seeing algal blooms every year. The Winston-Salem regional office tends to get a lot of phone calls about this. In particular, there's a black mat algae that has shown up recently. It's not a dispersed kind of like a green cloud. It's actually like a film, a thick viscous film. Has to do with the cell walls of each algal cell, and so they do form these thick mats. They float on the surface. They can be not only a toxic hazard, they could actually be a physical impediment in that they can get stuck in boat propellers and all sorts of nastiness. So they are pretty regularly occurring in not just High Rock Lake, but also other lakes in the area. As far as recent trends in water quality, there is a notable uptick in turbidity after 2009 and in fecal coliform after 2014. And that's in addition to the ongoing chlorophyll A water quality violations that it has seen over the ensuing decades. This is kind of in the weeds for this stage and for you guys, but just to give you a sense of sort of how we look at nutrients in the watershed and how we sort of make overall assessments of what might be causing the issue. The upper Yadkin main stem and Abbott's Creek arms are seeing point source influence in low flow years. This is straight from the most recent basin-wide plan that just came out a few weeks ago. Point sources, for those who might not be up on the jargon, those are wastewater treatment plants, anything that comes directly out of a pipe. Swearing Creek and Town Creek are dominated by non-point source influence. And so non-point source is anything that's diffuse over the landscape. Agriculture, stormwater runoff from urban areas, anything that just sort of flows across that's storm driven. And the lower Yadkin main stem is seeing increased nitrogen, but no increase in phosphorus. The conclusions we can draw from that can be difficult to ascertain. Here's a map of the impairments that we've seen over 2016, 2018. I do not have a map for the 2020 list, but it just gives you a sense that you see that Q466 station right at the top. It was blue in 2016. Everything else was impaired. Now everything's impaired. And so you've got a combination of turbidity up in the upper reaches and chlorophyll A, pH, turbidity, all the way from the beginning of the lake itself all the way down to the dam. There's a little stretch there on the very bottom left where there's just not enough data. But suffice to say, it's consistently impaired from one year to the next and has stayed that way. As far as nutrient sources to the lake, which may be combining to cause some of these issues, there are 242 wastewater permits, NPDES wastewater permits, 19 major, 124 minor, 99 single family, 81 wastewater irrigation fields, and 219 biosolids application fields. So those cover 200 acres and about 3,600 acres. That's going to be your biosolids from municipal waste, all the solids that get precipitated out of the wastewater. They get collected, the sludge gets collected, and then it gets applied. In addition, there are about 60 animal feeding operation permits, 47 cattle, 5 swine. So, I mean, you guys all know this much more than I do, but it's not a very swine-dominated area. There are 370 NPDES industrial stormwater permits. So there are some industry inputs in the area, 114 state stormwater permits, and then 11 what they call MS4 municipal storm sewer system permits. So that's going to be any big community that has a linked together infrastructure for stormwater flow management. They're actually regulated under the EPA rules for those MS4 permits. And there's a set number of requirements that come with that. The one note that I want to put in front of everybody here that tends to come up a lot in these discussions, and is something that we've had to respond to pretty regularly with some of the other stakeholders. None of these permits include dry litter poultry. Dry litter poultry is deemed permitted by the state. And so we don't know how many facilities are out there or where they are. Their waste does get reported as part of the regular ag rule reporting that the division does, Division Soil and Water does. But in terms of tracking actual permittees, we don't have any information on that front. So that's everything from me. I will stop sharing and pass it back until the rulemaking. I think Deanna, you're up.
Thank you, Joey. When are we all going to learn to unmute ourselves? We will be having a question session at the end, so thank you all for holding questions. One of the things that I wanted to say was that I was on a scientific advisory panel to set nutrient standards in High Rock Lake Watershed. And I can't remember exactly how long it took, but it was at least 3 years, if not 4 years. And so part of the reason I think rulemaking hadn't begun was that there hadn't been standards set. Couple things about High Rock Lake that made it really difficult is that it's got really great fisheries. It's got, and so on the one hand, it wasn't really seen as impaired because it had great fisheries. On the other hand, they were looking at how often the algae flipped into toxic forms. And that was very interesting. So at the end of the day, they were finally able to set a chlorophyll A standard, but it was not straightforward. It was not easy, and it took quite a time. So the next thing on the agenda is that I want to talk to you about a land use survey that we did about 10 years ago, because I think it informs you all. Some of you will have responsibilities. Let me try and get this up. Yep. Some of you will have responsibilities for urban. Some of you will have responsibility for ag. And I want to give, excuse me, I want to give you a flavor of what agriculture looks like in High Rock Lake Watershed. And again, this was done about 10 years ago, but I really don't think very much has changed in that time. And I want to acknowledge Kathy Neese, who worked with NCDA Statistics Division, as well as USDA National Agricultural Statistics Service. So let's just go ahead and talk about what we did. So one of the things about the watershed is that it has a little bit of red and pink, which are the urban areas. It has a ton of yellow, which means pasture or hayland, and then it has a lot of green, which are the forested areas. And I defy anybody to find the brown color, which is the cultivated crops. It's just really, really hard to see the cultivated crops. And so it is primarily an agricultural system based on pasture and hay, but the map is deceptive, as you'll see in some data I'll show you soon. So we did something called an area frame sample, and I'm not going to go through all the details of it. The dots that you see are the areas that we pulled samples from. The most important thing to remember is that we used a random number generator to select the fields that we went ahead and sampled, and it was a scientifically valid survey that we ran. Now, the people that helped with this survey were the people that affect agricultural statistics day in and day out. So they were well versed in how to do these questionnaires. The thing that was unique about this questionnaire is they not only did they talk to the landowner, but they also went out to every single field. And they collected information on everything from crops and tillage and conservation practices to actually pulling a soil sample. We had soil test phosphorus run in this watershed based on all the fields that we sampled. They collected information on slope and slope length, as well as the kind of livestock and the numbers of livestock. We had application rates for both fertilizer and organic sources of nutrients. And then we obtained additional information on fertilizer habits and demographics. And I'm going to talk briefly about many of these characteristics. Sorry. So now we're going to go right into the results of the High Rock Lake survey. So you'll note that over 1,500 agricultural fields were selected. We sampled just under 1,500 because of different issues that we found. On average, the field size was 12.5 acres. The thing that I find interesting is it doesn't matter which watershed or river basin you're in. On average, the field size in North Carolina is 12 acres. So we're talking about pretty small fields. The thing about this watershed that's different than some of the other surveys that we've done is that half of the people that we surveyed, it's their primary, ag is their primary income. 50% of the people we surveyed, it is not their primary income. So this is going to make how we think about working with stakeholders somewhat different. So let's talk about the land use in the High Rock Lake watershed. And I think you all probably already noted the counties that are part of this watershed. These are the counties that have enough land area in the watershed that we characterized it. And so we look at pasture, hay, winter crops, summer crops. It gets a little confusing between winter crops and summer crops because winter crops can also be on the same land that you have summer crops. So for the purposes of this discussion, I'm just going to talk about pasture, hay, and summer crops. So we had some counties like Watauga that had 100% of its agricultural land use in pasture. And then you get to places like Yadkin that only had 8% of its land use in pasture. However, when you look at Yadkin, it had the largest amount of hayland at 39%, and Watauga had no hayland. And so there's kind of a range in the percentage of hayland. But if you add pasture and hayland together in almost all of these counties, you're going to find that pasture and hay represent greater than 50% and oftentimes greater than 75% of land use. So that leaves us with the cropping systems. Yadkin far and away had the most number of fields in cropland, 45%. And again, Watauga had no cropland. So again, the watershed is not homogeneous when you look at land use. Livestock numbers, we found everything from llamas to buffalo to alpaca. So clearly this survey did a good job, but the predominant animals in the watershed were either cattle or horses. The only thing I want to say about this is that a number of the counties, it looks like the number of cattle they're running is a little bit greater than what would be recommended by the Animal Science Department. Okay, let's talk about conservation practices or best management practices. Here we have the different counties, and we have the number of cropped fields and the number of fields cropped with conservation tillage. So CT means conservation tillage. And we wanted to see how often the farmers were using conservation tillage. In Alexander, Iredell, Rowan, and Yadkin, for the cropped lands, 100% of the time, producers were using conservation tillage. Now, Davie stands out as not having as much conservation tillage, but most of the other counties have a considerable amount of conservation tillage. And this is going to be important when we talk about, well, what can farmers actually change? I'm not going to spend a lot of time talking about cover crops. Part of the reason is that 10 years ago, cover crops were barely being considered by farmers. The other thing about the cover crop information, and we knew this going into it, is it's not exactly clear to us which of these winter cereals are truly cover crops and which are actually going to be put into silage. So we see a smattering of different kinds of cover crops, and some counties seem to be more engaged, but I wouldn't put money on these particular data. What about riparian buffers? We were really interested in the percent of the agricultural fields that did not have a riparian buffer next to it. And when we say riparian buffer, it could either be a forested buffer, it could be a filter strip, a grass filter strip. It could be cows being fenced out of the stream in a very small strip of buffer. It didn't have to be a forested riparian buffer. So there were many states like Forsyth, Surry, Watauga, that all of their agricultural fields were buffered. The county that had the least number of fields that were not buffered was Alexander at about 50%. But again, if you look at most of the other counties, they're well buffered. The exception being perhaps Wilkes and then Caldwell. All right, let's talk about nutrient management, because nutrient management is one of those things that farmers can change, just like riparian buffers. I have an incredible amount of highly detailed data by county showing the amount of nitrogen put on the different crops grown in the county by county. And so if you want that information at the end of this presentation is the URL for this report. We have it on our website. But I thought the easiest thing to do would be to kind of coalesce the data. So fescue hay and fescue pasture have on average less than 25 pounds of nitrogen per acre per year, which is significantly less than they need. The reason for these low levels of nitrogen is that many hay fields and many pasture fields do not have nitrogen put on them. Now, the difference though, as you all know, is that fescue pasture is going to have nitrogen put on them from animal excreta, but as far as nitrogen being applied as fertilizer, there's not a lot being put on. Soybeans are getting about 10 pounds of nitrogen per acre per year because that's coming from the diammonium phosphate that the farmers are putting on. And when we looked at the other crops like tobacco and corn, they were receiving the appropriate rate of nitrogen. So all of the data combined tells us that the amount of nitrogen going on to fields in this particular watershed are less than the recommended nitrogen rates because there's a large amount of land in pasture and hay that's just simply not being fertilized. What about organic applications? Those of you that live in this basin, and you all live in this basin, know that there are a lot of chickens. And we looked at the application rates of chicken litter primarily. There's some dairy too. We also looked at that. And we found that there was a range of nitrogen and phosphorus anywhere from 10 to about 240 pounds per acre per year. Clearly, some of these upper levels would be more than the fields need for both nitrogen and phosphorus. 40% of the fields sampled were fertilized with P when we're just looking at phosphorus. Here's the thing that's a little disconcerting. The average phosphorus fertilizer on soils that were very high or high soil test P and actually probably don't need phosphorus, they're receiving on average 56 pounds of P2O5 per acre. Whereas soils that need phosphorus, medium and low soil test phosphorus soils, are only receiving 46 pounds of phosphorus. Clearly, the 46 pounds of phosphorus is either adequate or less than adequate, depending on the actual soil test. I just wanted to show you the soil test levels of the different counties. Remember, we pulled soil samples in every single field that we sampled. And what you'll notice is we have both the minimum, the maximum, and then the weighted mean. So it means we looked at the number of acres times the phosphorus rate, and then we looked at the mean. So if you look at just the mean, the average soil test ranged from very high in Alexander, high in Iredell, and very high in Wilkes, to rest of the counties having high soil test phosphorus with the exception of Stokes and Forsyth. And so there are some really high soil test phosphorus levels in this particular watershed. The highest that we measured was around 850 Mehlich-3 phosphorus, which is a lot more than you need to grow a crop. There is a tool that some of you may know and some of you may not know, called the North Carolina Agricultural Nutrient Assessment Tool. And this tool looks at relative risk of nitrogen and phosphorus. And when we look, we didn't even run it for nitrogen because we know that less nitrogen is being applied than the farmers actually need, but we ran it for phosphorus. And there's a lot of detail here, and that's not what's important. What's really important is that the phosphorus rating losses for all of the counties in High Rock Lake Watershed were low, with the exception of Alexander. So this makes us wonder what we can really do in this watershed. So getting to the conclusions, again, most fields were under-fertilized for nitrogen. We found that farmers use the same fertilizer rates if they're fertilizing the same crop. So farmer A has a way that he fertilizes all of his corn crop. Farmer B has a way that he fertilizes all of his corn crops. It's different than farmer A, but they use the same formula for all of their corn. Tobacco was the exception. The farmers were taking a lot of care with their tobacco, but as all of you know, there's less and less tobacco in this watershed. There was high use of soil testing. Almost all farmers soil test. We found that on average, the county soil test levels were high or very high. This is not surprising. This looks like the rest of North Carolina, but not surprisingly, the farmers weren't matching their soil test recommendations to applied phosphorus. We also found that there were very few nutrient management plans, and we just saw low losses of nutrients using this predictive tool, NICNAT. So the cropping systems in this particular watershed lead to really low erosion because you have pasture or hayland, and the majority of the small amount of cropland is under conservation tillage. Buffers are frequent in most counties. There are a couple counties where you could probably add buffers. And so where are we in thinking about nutrient management and the agricultural rule implementation? Well, we have no idea what the agricultural rule is going to look like. So it's a little hard to talk about implementation. But here are some talking points that the agricultural community will need to visit. And by agricultural community, I mean extension, soil and water, and of course, most importantly, the producers. So there are a number of counties where we could add some buffers. These don't have to be forested buffers. They can be just grasses. In many counties, because of so many pastures, we're going to have to put in stream fencing to keep the cows out of the creek and out of the riparian buffers. It looks like a couple counties, they can reduce their livestock number. And then, of course, there's the whole discussion around animal waste. So there were a lot of people that helped with this work. It was an enormous project, as you might imagine. This is the URL for finding this report if you're interested in it. Probably if you Google NCSU extension High Rock Lake, you'll bump into this report. But if you can't find it, please let me know. The next presentation is going to be by Allie Dinwiddie, and she's going to be talking about the rules in other basins to give you an idea of what other places have done.
So as Deanna mentioned, I plan to give just an overview of the existing agriculture rules that we have for other watersheds and river basins in the state that are under nutrient management strategies that are looking at being developed in the High Rock Lake Watershed. So some of the existing rules that we have are the Neuse River Basin agriculture rule and the Tarp-Pamlico River Basin agriculture rule. We also have two additional rules that I'll cover in the next slide for Jordan Lake Watershed and Falls Lake Watershed. So each of these rules are slightly different for the non-point source nutrient reductions for agriculture. So on the slide, you can see that there's a 30% nitrogen loss reduction required for the Neuse agriculture rule, as well as for the Tarp-Pamlico agriculture rule. And these rules were established, earlier in the 2000s or in late 1990s. And the baselines for those rules were established slightly earlier than that in the early 1990s. So these rules require an annual report on agricultural activity, and agriculture, importantly, is regulated collectively. So it is collective activity that is reported through a process that I will go over in later slides. So to cover some of the other rules, besides the Neuse and Tarp-Pamlico rules, we also have the Jordan Lake Watershed, which is in the Cape Fear River Basin. And that has regulations for nitrogen and phosphorus loss, as you can see on the slide. So those regulations are by 3 sub-watersheds. So they have different nitrogen and phosphorus losses associated with each of those sub-watersheds that are allowed. And it also requires an annual report on collective activity. Falls Lake Watershed, which is a sub-watershed within the Neuse River Basin, also has a separate agriculture rule, which has staged reductions. So it has a stage 1 reduction, loss reduction for cropland and pasture land, and a stage 2 nitrogen loss reduction from cropland and pasture land. So the Jordan Lake Watershed and the Falls Lake Watershed have reductions associated with cropland and pasture land. The Neuse River Basin and Tarp-Pamlico are cropland, are regularly cropland losses. So just to give an overview map of where these strategies are in existence and which strategy is under development. So Joey shared and Deanna shared a graphic of the High Rock Lake Watershed, but you can see that it's part of the Yadkin PD River Basin. So as far as reporting hierarchies for the current rules, these rules establish local advisory committees. So for the Tar Pamlico and the Neuse River Basin, there's 25 counties between both of those river basins, and there are local advisory committees that were established that include representation from Division of Soil and Water Conservation, Natural Resources Conservation Service, Soil and Water Conservation District staff, Cooperative Extension staff, Department of Agriculture and Consumer Services, so regional agronomists that cover that area, those particular counties, and agriculture producers serve on those local advisory committees. And those local advisory committees every year collect and review data on what agriculture is collectively doing to reduce the different nutrients that are regulated under those agricultural rules, so nitrogen and phosphorus. And so the local advisory committees put together annual reports on activity within their county, and then that is submitted to Division of Soil and Water, which puts together a report for the basin oversight committees to review. So the basin oversight committees exist for the Neuse and Tar Pamlico River basins, and membership for those committees includes Division of Soil and Water staff, Natural Resources Conservation Service staff, Division of, Department of Agriculture and Consumer Services, Cooperative Extension, Division of Water Resources staff, and up to 2 environmental interests, academics, and 1 to 3 agriculture interests. So membership on the watershed oversight committees is very, very similar. A lot of the same partners are there. There's just slightly different membership categories for environmental, and there's up to 4 agriculture interests that serve on those committees. And those committees oversee what agriculture is doing in the watershed and put together reports for Division of Water Resources on activity. If agriculture is not meeting the required nutrient reduction amounts annually, then there's other steps that the basin oversight and watershed oversight committees can take. But luckily we haven't run into that situation in any of the existing basins and watersheds under nutrient strategies. So the data that we use in the annual reports that are put together that the Basin Oversight Committee reviews and approves every year is crop acreage data, so that it depends on the watershed and the river basin, but that data comes from either Farm Service Agency or the USDA National Agriculture Statistics Service crop data that is available publicly. And then there's, we use data from Agriculture Statistics Service for livestock data from that source. And agriculture census data. So either the survey data or the census data for livestock numbers. We also include select BMPs that are implemented using state and federal cost share funding through the Agriculture Cost Share Program or NRCS EQIP. And then fertilization rate application data is included in the reporting, and local advisory committees weigh in on what data should be included for those rates. And then local knowledge and data on farmer implemented nutrient reducing best management practices that were not supported by cost share funding is included in this process. So how does agriculture collectively meet the nutrient reduction targets and get credit for nutrient reducing activities with the existing rules? So agriculture, nitrogen in these basins and watersheds under nutrient strategies are our reductions in the agriculture nitrogen are estimated using an accounting tool called nitrogen loss estimation worksheet. And this is similar to what's in NICANAT, which Deanna mentioned, but this was scaled to the county level and based on acreage and other information within the watersheds and basins that it is able to be run for. And it was developed by an interagency technical group with folks from Division of Water Resources, Division of Soil and Water Conservation, Natural Resources Conservation Service, and NC State University. And NLU captures both inorganic and animal waste sources of fertilizer and estimates changes in nitrogen loss from cropland and pasture land. And like I said, it was scaled to the county level and aggregated to the river basin scale. So the BMPs that counties can report that receive nitrogen reduction credits through NLU include unfertilized cover crops for the species listed on the slide there, water control structures for those in the east, riparian buffers, 20 to 100 foot, including filter strips and field borders adjacent to blue line streams. Implementation of livestock exclusion systems also provides nitrogen reduction credit for the pasture land regulated reductions required in falls in Jordan Lake. So there are additional nutrient reducing BMPs that I've included on the slide there, just a couple that districts and NRCS implement that the agriculture communities do not receive reduction credit for through NLU, and they're listed on the slide. And underlying assumption for that is because in NLU, the majority of nitrogen lost in these cropping systems is lost through subsurface soluble nitrogen. So most of these practices that are included there are erosion practices, and although they're effective at reducing erosion and surface losses of nitrogen, they don't have a proven effect on a majority of the nitrogen loss that we see in these agricultural systems. So NLU is most importantly a great tool for estimating the baseline in nitrogen loading for agriculture and then tracking nitrogen reducing best management practice implementation over time and changes in nitrogen losses. So that's really where the tool shines. When considering phosphorus losses in these basins and watersheds, what was established as far as the accounting procedures was qualitative tracking of relative changes in agricultural practices, land uses, and management that either increase or decrease the risk of phosphorus loss in these from agricultural lands in these basins and watersheds on an annual basis. And this was an accounting approach that was approved primarily because of the difficulty of aggregating and scaling up the phosphorus loss tool, similar to what we were seeing ability to do that with the NLU tool. So with that, I think that was a brief and fast introduction to what we report and some of the information about our nutrient strategies and agriculture rules and the other watersheds in the state of North Carolina, and welcome questions at the end of the presentations today, or you have my contact information on the slide.
Our last presenter is Joey Hester.
The big question, given all of this information, is sort of where do we go from here? What happens next? The rulemaking process is long and cumbersome, and it has a series of steps that happened in the past that are kind of a logical sequence that all culminate with the formal rules that will be adopted at the end. The impairment determination, we already covered that. That was the 02 to 04 timeframe. For the model, we did intensive water quality monitoring over the 05 to 10 timeframe. The watershed model development took place over 2010, 2012. That's a characterization of land use and watershed sources of nutrients. The lake response model was developed for 2010 to 2016. That then is a model that predicts how chlorophyll A numbers will respond to particular inputs of nutrients from the watershed. The nutrient criteria development process, not going to get too heavy into that, but that's the one that Deanna mentioned earlier, that determined, essentially was a re-investigation of High Rock and said, okay, we have this existing state water quality standard, 40 micrograms per liter. Should we investigate High Rock specifically and figure out if there's a better, more specific number for this lake in particular, rather than just a one-size-fits-all approach? So that took place over the last few years. It is technically still going because we don't have a finalized water quality standard for High Rock just yet, but that is in process. So future steps for where we go from here and how you guys can help us and get involved. There have been internal planning discussions that have happened just for Division Water Resources, some subject matter experts. We've had a discussion with Julie and Allie. Informal stakeholder outreach is ongoing right now. We have started some small virtual meetings that just introduce what the nutrient strategy concepts are, how these rules work, what we plan to do as far as timeline, and how we plan to reach out. Technical stakeholder work groups will follow. They are going to be small virtual or in-person meetings, likely between, say, April and July-ish. They will include subject matter experts. We're going to brainstorm rule concepts, and it will be contracted facilitation. So we have a third party who will be doing sort of the mediation for keeping everybody on schedule and keeping disagreements between groups sort of on track. Formal stakeholder engagement will be at the tail end of some of those technical work group sessions. They will probably be what you guys can expect from a public hearing type process, large room, on auditorium scale, in person, contracted facilitation again, and then some sort of consensus-based decision making to come out with a sort of path forward. Rule drafting, we will then go back after we've gotten a lot of feedback from stakeholders. We'll come back and I will sit down with my folks in DWR and potentially some subject matter experts and actually do the language drafting we're hoping the latter half of this year. Formal stakeholder engagement will follow. We'll come back out to stakeholders and say, okay, well, here's what we drafted. Here's what we're proposing. Now you tell us what you think. Pick it apart, blow holes in it. And then once we go through that sort of back and forth process, the rules would get submitted for rule approval. Then it would have another set of public hearings and comment, but that's more sort of legislatively driven. 60 days, formal comment, you have to submit via the website. We have to then write a response, EMC approval, and then Rules Review Commission approval. So those last few steps, I've squeezed a whole lot of information that we have to deal with into just a few different things. But by far, the most cumbersome and time-consuming process will be 8, 9, and 10 there to get all of those, because the EMC can move forward or kick it back and delay. And there's a lot wrapped up in those last few steps. Here is a very tentative, very optimistic timeline for what we're expecting moving forward. I boiled them down into those major points that you saw on 1 to 10. This takes us out to the early stages of 2025 before these rules will actually be enforceable and sort of on the books officially. This is assuming no major hiccups and no major setbacks. As I'm sure all of you can expect, we will probably have some hiccups and setbacks and some ongoing disagreements that we need to sort through. So this is just our best guess at how things would move forward. We have a number of years before this will come into enforcement. We have plenty of time to try and get it right. And we intend to get feedback from stakeholders to make sure that it works for everybody. I just wanted you to sort of come away with a take-home message that this will not hit the books at the end of the year and all of a sudden you have to adjust. This is going to be a process of sort of bringing everybody up to speed on what this means for them in the future. And that's the end. 2 things that I wanted to mention, and maybe I'm blanking on the second one, but we are initially focusing on phosphorus for this strategy based on discussions with stakeholders, some of the information that we've got, that we've gathered. There will likely be a phosphorus focused approach on these rules. That's the first time we've ever done that. There are phosphorus limits in Falls Lake, but primarily the other rules have been focused on nitrogen with the NLU scalable tool. This will be the first one where we're actually looking at it through the lens of phosphorus, and that's going to dramatically change the possibility for what these rules can do and what we expect to see. And so at this point, we are just brainstorming about what that could possibly mean and have not made any decisions. So it's still very much up in the air. And I don't remember what the second one was. So we've got a few minutes left for questions.
What should we be telling producers? Is it share the timeline, let them know what is your thoughts on that?
Well, I'd let them know, first of all, they're in the High Rock Lake Watershed if they don't know that. Not everybody knows their location. The second thing to let them know is that the lake is on the impaired list, which means that the state of North Carolina is obliged to do something under the Clean Water Act. So that's the second thing. The third thing is to let them know that there's rulemaking that's going on right now, and it's better for them to be part of it and help craft the way it goes than to be on the receiving end and to be told what they have to do. So I would get the ones that you can engage. This is a difficult process. Most people don't understand it and don't have time for it, but I would start readying your folks. Joey gave a timeline. He was absolutely correct. I would put money that it won't make that deadline. I know they're going to try real hard, but having watched this previously with some of the other ones, so you have a couple years to start working with your stakeholders. The other thing is that if you guys want presentations developed, I'm more than happy to help you develop those. And I'm sure Joey and Allie would be happy to help too, or they'd be willing to provide education, for me, that's what I'm thinking. I don't know, Joey or Allie, do either of you have anything else?
I have one point that I think is the driving dynamic of every conversation we have had with any stakeholder every single time we sit down. And Seth, I want you to make sure that they know we are not singling them out. When I sat down with wastewater dischargers, they said, well, why are you singling us out? What about them? And them is just sort of everyone at large.
Everyone else.
When I sat down with home builders, they said, why are you singling us out? What about them? And then when I sit down with municipalities, why are you singling us out? What about them? And I expect to see the same thing from agricultural producers. Everyone feels like this is like, why are you hitting us with rules? It's not our fault. That's one thing that it'll take us years to overcome that embedded perception. We are statutorily obligated to move forward with a strategy that is as fair as we can possibly make it. And when farmers say, well, are you going to regulate golf courses? Tell them yes. To the extent that we can legally, we are going to address as many of those non-point source issues as we possibly can. And no stone will be left unturned. We have limits on our end about what we're authorized to do, but I promise you, we are not trying to pick on anybody. Everybody seems to think that that's what we're doing, but we are trying to be as fair and reasonable as possible, given that this watershed problem is not the farmer's fault. It is not the municipality's fault. It is sort of a death by 1,000 cuts. Over all of the years, these little tiny contributions of nutrients have led to this place where we need to start thinking systematically about how we reduce those loads.
And I'm about ready to say something that probably DEQ doesn't want me to say. These are reservoirs. These are man-made reservoirs that exist in the South. Joey alluded to this when he started his presentation. They are oftentimes eutrophic when they fill up, just by virtue of what they are. And so that makes them really hard to deal with. And I think it's important that helps not place blame, is just to know that it's a function of the system. Are there any other questions? Julie, you want to say something?
Yeah, I do. I actually have a question for Joey. So I wanted to pause and let other folks have a chance first. But since this strategy looks like it may be very different by targeting phosphorus, do you all have any ideas how that's going to work? And for from Allie's presentation, we use a qualitative phosphorus accounting tool currently, not a quantitative. So I don't know how we'll run these numbers and what that workload would look like. So if you could share any ideas y'all are thinking of, that would be great.
We are asking questions that go much deeper than just how will we measure this. We are questioning whether NLU would be feasible here. We know the limitations of plat. We understand that phosphorus is a very different beast, and aggregating at scale leaves us with very few options there. And so I think conceptually, from sort of how the rule works, we are examining numerical mandates on a fundamental level. We don't know. I don't know what I've started developing a matrix of every possible rule stipulation, every piece of requirement that we could put into rule language to say, okay, well, if we did this, how would that even, is it enforceable? Do we have authority for it? And would it actually achieve any results as far as water quality is concerned? We're at that stage where we don't even know what's possible, what's feasible to move forward. So the short answer to your question is very much, I don't know. But on the positive side of things, I think because we're looking at this from a phosphorus perspective, it opens up the dialogue to say, well, we can think about this differently. We can think about the ag rule on a very different level than the other ones. We're not sort of wedded to the existing infrastructure that we've built in the other rules. And I don't want to use that. I don't want that to be interpreted as in any way undermining all the work that Deanna and you guys have put into the other rules, because they have taken years and years and years of work to get these things into motion. But I think we're looking at sort of what the next phase of these nutrient strategies should look like. And Deanna's point is well taken. This is a freshwater reservoir that will collect nutrients no matter what we do. And in a lot of cases, with some of the research that we've seen from the Jordan Lake and Falls Lake watershed, you're seeing legacy contributions from nitrogen that was applied 40 years ago. And there are some of these impacts that are just sort of baked into the system. And so I am making a concerted effort to remind everyone in these internal discussions that we shouldn't expect results quickly. We shouldn't expect this watershed to just turn around overnight and all of a sudden be healthy and wonderful. We should expect this to be a very, very long process, and being overly punitive on any one particular source we know is going to be counterproductive. So we're trying to be flexible, and we really don't know how a phosphorus strategy would work with the agricultural sector. But we do know that everyone's expecting us to look at ag very closely. And that's just the name of the ballgame.
So for those of you in extension, I think the thing that Joey just said is really important, that they're going to be looking at ag very carefully. And so I would urge you to get involved. I just want to mention one last thing. There's a new water program team that's starting. There are 4 different subtopics within the water team. One is called Urban and Ag Water Quality. I'm chairing that along with Mike Carroll. And as far as we're concerned, this is kind of our kickoff event. We're recording it. We'll get it on the website. Please, we will make sure that we send out emails to other agents. I think it's really important to get the ag community involved in the decision-making, the rulemaking. So with that, it's 10 o'clock on the hour. I want to thank Joey again, and also Allie. You all know where I am. If you have any questions, give me a call or email me. And if you have questions of either Joy or Allie, we will get them to them. So thank you all very much for attending today, and we'll get this online. So if you want to see it again, you can. Thank you all.
Thank you, Deanna.
Thank you.
Bye.